All right, number 4. John Q. Bonehead decides that it would be a good idea to drive when he shouldn't. Fortunately, he gets pulled over before anything tragic happens, and a blood alcohol concentration test finds a level of 1600s at 2 a.m. Unlike most other drugs, studies have shown that alcohol leaves the bloodstream at a constant rate. The table shows his blood alcohol concentration every hour after the arrest. Okay, so they're asking on number 4, what is the slope of the line describing John's blood alcohol concentration? So they already told us that it leaves at a constant rate, so we know that finding the slope, it's a good idea, and that we're going to be having a line here to model this situation. So let's use 0, 1600s, and we'll go ahead and use 4, 1/10. So let's do in the numerator 1/10 minus 1600s. The denominator, let's do 4 minus 0. Okay, so in the numerator I get 600s divided by 4, and I'm sorry, that should be a negative 600. Sorry about that. Divided by 4, and when I divide, I get negative 15 thousandths. And what does that tell us? This is in a context, so this is important. It means John's blood alcohol concentration is, now since this is negative, we'll say decreasing at the rate of, that's going to be 1500s per, okay, what was our units? Okay, that was hours, per hour after 2 a.m. All right, then they asked, what is Y-intercept of the line describing John's blood alcohol concentration? Remember, with the Y-intercept, your x-coordinate is always going to be 0. So that makes our Y-intercept, and that means his blood alcohol concentration was 1600s at 2 a.m. That's a starting blood alcohol concentration. All right, now they want us to write an equation describing John's blood alcohol concentration, with X representing the hours after 2 a.m. and Y representing the blood alcohol concentration. So, Y equals, okay, what did he start with? 1600s. It was a decreasing by 15 thousandths per hour. So on 7, when using an equation to model a situation, it's important to recall what specific information the equation provides. Restate your answer to question 6 in the form of a statement like this. So I'll go ahead and use their model. If X represents, let's see, hours after 2 a.m., then Y equals, and we're going to go ahead and put our equation here because it said Y equals, indicating that's what they wanted, represents, so what was the Y? Blood alcohol concentration. Okay. So number 8 is asking that you use your graphing calculator, your Desmos, or what have you, to find a table, look at the graph, and see if you can't use technology to model the situation. So let's go ahead and go to number 9. What would Mr. Bonehead's blood alcohol concentration be at 3:30 a.m.? So they're just reminding you, some people say if you eat greasy food, that'll help sober you up sooner, and they're finding that time really is the only thing that does that. So that's an hour and a half after 2 a.m., right? So we're saying that X is 1.5. So using our equation, we have y equals 1600ths minus 15 thousandths times 1 5/10. And that's going to give us 1,375 10,000ths. Okay, not sober yet. 10 says, how many hours would it take for his blood alcohol concentration to drop below the legal limit of the 800? So that's an inequality, isn't it? We want it to be less than. So let's use our expression for the blood alcohol concentration on the left side. Probably needed to not provide as much space as that. Now let's go ahead and solve this. So we get negative 15 thousandths x is less than a negative 800ths. Now let's divide both sides by a negative 15 thousandths. We're dividing by a negative. What do we have to remember to do? Change the direction of the inequality. And so no doubt you're going to get like 5.33333. So that's 5 1/3 hours. And most of us know that that's 5 hours. What's a third of an hour? 20 minutes. Okay. So he better find a couch to sleep on before he starts driving, or either get a cab.